Hello everyone and welcome back. I am Mr. Cobalt and today I'm going to go over how to predict the products of a precipitation reaction. And this actually will apply to a lot of different equations or reactions like acid-base neutralization or gas evolution reactions. But we're going to start with precipitation reactions. A precipitation reaction is where a precipitate forms, and a precipitate is basically a solid that forms during the reaction. So we call it a precipitate. Um, so the reaction that forms a precipitate is called a precipitation reaction. So it makes sense. So how do you predict the products of your precipitation reaction or any reaction, right? Or if you have two substances. So this is going to work mainly with ionic substances that are mixed together. And so if I write a generic equation, you can see what I'm going to do here. So if I have one substance, an ionic substance that's AB, and that's in aqueous, and that means it's dissolved in water. And then I have another substance, let's call it CD, and that's aqueous, and so that's dissolved in water, right? And so I'm given these two reactants, and I'm asked, what are the possible products? Well, to figure out the possible products, you have to figure out, well, what are the different combinations? And so what I want to first say here is, if this is an ionic compound, which they most likely will be, then the first one is going to be a positive ion, the second one is going to be a negative ion. Same thing with this one. This is going to be an ionic substance. And so that's going to be positive and that's going to be negative. Well, there's only one other way that you can rearrange this to form what are possible products, right? You don't know if these products are going to form, but what are the possibilities? Well, if this is a positive ion, if C is positive, then there's only one other negative ion it can go with, because positive can only go with negative and negative can only go with positive. So this positive ion is already with D, which is negative. So the only other negative ion is B. So C and B going together is the only other possibility, right? So you would take the two inner ions, C and B, and you would put those together as a product. So, and then the positive ion is written first, so C and B. So Cb, these two ions being brought together, would be a possible product. And then that only leaves A and D, so you bring the outside ones. So the outside ions, bring those together and you get a D as a possible product. Now, why do I keep saying possible product? Well, what we're doing is we're putting these together theoretically, saying, well, these might interact and come together to form a solid, right? Right now, we are writing them together, but notice this is aqueous. So this is an aqueous solution, meaning that A and B really are not together. A and B are separate ions floating around. So they're not really together interacting with each other. The same thing with C and D. So again, it's aqueous. So C and D, even though we wrote them together, are really not together in solution. They are floating around and by themselves. So not by themselves, but they are floating around separate from each other. And so that's what aqueous means. So if you had this in a beaker, right? So we have this in a beaker and this in a beaker or test tube, right? So we have two different solutions in two test tubes. So we have ions floating around in solution and we have ions floating around in solution. They're not interacting with each other. They're not coming together to form a solid. They're just floating around. we're asking here in this problem, what's going to happen when we mix all of these ions together? So if I put C and D and A and B together with all these ions floating around, the question is being asked, will any of these ions come together to form a solid, or are they just going to continue to float around? And that's what the solubility rules are going to do. So if I look at my solubility rules and I see that when C and B come together, they are soluble, then C and B is going to be aqueous. So these guys are just going to keep floating around in solution. Right, so nothing is going on, nothing happens. So that's really not a product that formed because they're just floating around in solution. So C was floating around in solution here, but it was floating around in solution before as well, so there's no change. Same thing with B. B was floating around in solution now, but it was floating around before, so no change. Now, if I look at AD and I look on my solubility chart, and it turns out that A and D are, when they come together, they interact and they are insoluble, that's an insoluble salt, then that means that that's going to precipitate and become a solid because it's insoluble. And so that would be a solid. And so if this is the case, then the one product that I form is AD because I formed a precipitate. So that is my product. And everything else is just floating around in solution. So I have my C and B are floating around in solution while my A and D come together to form a solid. And so that would be an example of a precipitation reaction. What if I look on my solubility chart and AD is also soluble, meaning it is in aqueous, so they're just floating around in solution. So in this case, when I have this beaker of AB solution and I have A and B ions floating around separately, and in this beaker I have C and D ions floating around separately, they're not really doing anything, so and then I mix them together into one large beaker, right? So here's my large beaker. And so now I have C and B aqueous and A and D aqueous. Well, all this means is that C and B is still floating around separately in solution, and A and D is floating around separately in solution, right? So I've gone from two separate solutions where A and B and C and D are floating around separately, and then I put them all together and they're all floating around separately. So nothing's coming together. So in this case, where I go from two aqueous solutions to two aqueous solutions, then there's no reaction, right? Because nothing has changed. I've gone from ions floating around solution to ions floating around solution doing nothing, right? So this would be an example of no reaction. So if this was the case, I would write no reaction. Okay, so if there's no precipitate forming, then there's no reaction. Now, let me specify something or clarify something. If you have a liquid form, if you have two aqueous solutions and you form a liquid on the other side, or if you get a gas on the other side, then you do have a reaction as well. But here, we're going from aqueous to aqueous, and we're specifically looking at precipitation reactions. So since there's no precipitate forming and we have aqueous, then that means that there's no reaction. And so we would say no reaction. Okay. Later on when we do the acid-base neutralization reactions or gas evolution reactions, we'll look at gases and liquids and stuff like that. So let's do a couple of examples so we can see how to do this. So a typical example is going to give you two reactants and they're going to give you the name. So here it says write an equation for the precipitation reaction that occurs, if any, when solutions of potassium carbonate and nickel 2 chloride are mixed. So those are the substances that I'm mixing. So in order to write, I need to write the formulas, and so I need to know the names to do this. So I'm going to write the formulas. So this is potassium carbonate. So potassium carbonate is going to be K2CO3 aqueous. And then we have nickel 2 chloride, and that's going to be NiCl2 aqueous. And so the first thing I want to do is I'm going to predict my possible products, and that's what I'm going to do. I'm going to take the inner ions, so the nickel and nickel 2 and carbonate. I'm going to put those together, so that's going to give me nickel 2 carbonate. Carbonate. And then I'm going to take the two outside ones, so I'm going to put potassium and chloride together. So that's going to be potassium chloride. Okay, so now I have my possible products. So before I do that, let's balance the equation. So I have 2 here, I have 2 there. And then the great thing about polyatomic ions is that you can treat them as one group. So I have CO3, CO3, so that's 1. I have 1 nickel, and I have 2 Cl, and I have 2 Cl. So now it's balanced. So now what I would do is I would look at the solubility chart and say, okay, do I have precipitate? If I look here, I remember chlorides and potassium are soluble. So potassium is soluble in water, and there's no exception. So this is going to be aqueous. And then from the other part of the table, carbonates are generally insoluble, except for those exceptions, but nickel 2 is not an exception. So nickel 2 carbonate is going to be insoluble. So that's going to be our precipitate. So that is our product. So this is a reaction. Now, what about this one? Now, I shortened it, and so basically it's the same question, but instead of potassium carbonate, it's nickel and nickel 2 chloride, it's sodium nitrate and lithium sulfate. So let's do this one really quickly. So we have sodium nitrate, which is NaNO3. That's going to be aqueous because nitrates are soluble. And then I have lithium sulfate, SO4, that's going to be 2Li2SO4, and that's going to be aqueous. And then I'm going to predict the products again. So the product, okay, so I take the inside ion, so lithium, lithium and nitrate, so the NLiNO3, and plus the 2 outside, so sodium and sulfate in it too. And so now what I want to do is I want to predict the product. So I look at my solubility chart and I see, okay, lithium, nitrates are always soluble. So this is going to be aqueous. So there's no exceptions to nitrates. Nitrates are always soluble. And I got sodium sulfate. So sodium sulfates, sodium is always soluble. So here we always have, this is aqueous. So both of these are aqueous, meaning I just have ions floating around in solution. So I've gone from ions floating around in solution to ions just floating around in solution. Nothing's coming together, so there's no reaction. So there's no products are being formed. So I write no reaction. And that's how you use your solubility chart to determine whether or not you get a product or a precipitate in this particular example. I hope this was clear and helpful, and if you like this video, go ahead and like it, subscribe to the channel, share this video with your friends, and make a comment in the comment section. Let me know what you think, and ring the bell so that way you can get notifications for when I put out more videos. Thanks for joining me, and I'll see you next time.